Okay, hi everyone. So we're looking at exercise 3K today, and there's lots to find out, so let's get moving. And so what actually do we mean when we talk about a family? Well, what we're saying is that it's a set of expressions which share a common feature. So if we look at this one here, we've got the y equals ax squared. What we notice is there's going to be a series of parabolas, all with their vertices at the origin. So you might have one like that. That might be, say, 2x squared. That might be 1x squared, that might be half x squared. So it's a family of expressions or equations which all share a similar feature. And so in this one, we just remember that these letters, the A, the B and the H, have got a special name. We call them parameters. So looking at the example we've got here below, we've got for y is equal to ax squared plus bx, and we're actually varying the values of a, and we're varying the values of b, and you can see what all the different graphs end up looking like. Okay, so looking at this particular question, we're told that the rule is y is equal to ax squared plus c, and our task is to find out what the a and c are equal to. Now, generally speaking, if there's two unknowns to find out, there's generally going to be two pieces of information which are given to us. So what it means is we just need to substitute those in, form some simultaneous equations, and then solve those simultaneous equations. And that's exactly what's happening down here. So we get the two simultaneous equations. 7 is equal to a plus c, 10 is equal to 4a plus c, and then we just go ahead and solve them. And so from here we get a is equal to 1, and we get c is equal to 6. So that means our equation is, even though it wasn't asked for in this particular question, our equation is y is equal to x squared plus 6. Okay, so let's look at this particular question. And so what we notice is we've got parabolas in this particular form here. Incidentally, let's notice that the y-intercept is going to be 2. And in the first part, we need to try and find out what a is in terms of b using this little clue here. And that clue is that the turning point is on the x-axis. That means that what's going to happen is the graph's going to come down and just touch at one particular point. This means, therefore, that if we're trying to work out the discriminant, it must be equal to 0 because there's only one solution. So that's our first step, and that's to let the discriminant equal 0. Well, in this particular equation, we've got ax squared plus bx plus 2, so that our a is equal to a, b is equal to b, but c is equal to 2. So that when you do b squared minus 4ac, that c is going to be equal to 2. Therefore, we've got 2 times a 4, and now we've got b squared minus 8a. But we already know that b squared minus 8a is going to be equal to 0. So if we know that b squared minus 8a equals 0, we therefore know that negative 8a is equal to negative b squared, and we know that a is equal to positive b squared all over 8. And that is what's sitting here. And so that answers the first part of the question, where we had to express a in terms of b. Now in the second part, I'm going to show you one way that I would do it. Next slide, I'm going to show you another way that I would do it, both of which are actually different to the way they do it in the textbook. Now, I would argue that since we now know that a is equal to b squared over 8, we can substitute that into here. And that's exactly what I've done. I've made that b squared over 8 times x squared plus bx plus 2. Now, in order to find out what the b is equal to, I'm just going to substitute in that 4, 0 there, because I knew that it actually went through the point 4, 0. So I know that point is going to be on the line, so I can just substitute that in. That's what's happening over here. And when I've simplified that and factorised it, I get down to this point here. We've got 2 times b plus 1 all squared is equal to 0. So that means, using my null factor law, b is equal to negative 1. But we remember that a, right over here, was equal to b squared over 8. So what I now do is substitute in negative 1. Negative 1 squared is positive 1, and so therefore I can now say that a is equal to 1 over 8. Okay, so as promised, here's the alternative way of looking at that particular question, and that is by saying that if the turning point is going to be at 4, 0, the expression can also be written in the form y is equal to a times x minus 4 all squared. Well, if that's the case, which it is, and we also know that 2 is the y-intercept, that means we can substitute 0, 2 into this expression. That's what's happening here. We've just substituted in 0, 2, and from here we get 16, because negative 4 squared is equal to 16 times a is equal to 2. Divide both sides by 16, and then we get the a is equal to 1/8 answer that we got before. But it's not quite what we're after, because we wanted to get what a and b are equal to, so we actually need to expand our expression, and that's what's happening here. I'm going to expand x minus 4 all squared, then I'm going to multiply through by the 1/8, and that's what I'm doing. So 1/8 times the x squared just equals 1/8 x squared. 1/8 and that 8 there cancels down to leave you with minus x, and then 1/8 times 16 is equal to 2, and so we've got our expression that we had before. In the meantime, we already knew that the a was equal to 1/8, but because we wanted to find out what the b was equal to, the b is the coefficient of the x, so it's equal to -1. And of course that's the same as what we got before, so we're feeling quite satisfied with ourselves. And so in a sense I've kind of preempted one of the ways of doing it, and you might recall that we just spoke about the one with the turning point in it, so that was the actual method which I used. Now we didn't use the plus k in that case because the turning point was actually on the x-axis, so the k would have been equal to 0 with that particular one. But let's have a look and see what's going on here. In order to determine the rules, there's 3 different ways of expressing the functions. You can put it in this fully factorized form here. Now if you do that, that means you've got 2 axis intercepts. So what you'll be faced with is questions where you're given certain pieces of information, and depending on what information you're given, that will determine which one of these 3 equations you're going to begin with. So how do we know which one to use? Well, as we can see, we're going to use the first one if we've got 2 x-axis intercepts and the coordinates of another point. That might look like this. Oh, bad diagram. Let's try another one. Might look like this, where you know the 2 x-intercepts and you know another point. Might be the y-intercept, but you just know another point. So you would just use those values in that case. Let's rub that out. This one was the one where you already had something in turning point form, and if you know one other point. So that turns out to be quite a useful thing, because we can just use the turning point to work out what our h and k are equal to immediately. So that's why that one's actually quite a useful one to know. And the last one is if we're just given 3 random points anywhere on the parabola, we're going to have to use this form, ax squared plus bx plus c. So looking at this first example here, we're told we've got x-axis intercepts at -3 and 4, and it's passing through the point 1 and 24. So we've got a choice between these 3 here. Which one are we going to use? Well, we're going to use number 1 because we've got the 2 axis or x-axis intercepts, and we know one of the other points. So we're definitely going to use the first one here. Let's see how it works. So because we know that we've got intercepts at -3 and +4, that means it's x plus 3 in the brackets, x minus 4 there. And so the only thing we need to work out is what the a is equal to. How do we do that? We set this point 124 in, and then finally we bring it all the way down here and we work out that a is equal to -2. This means we now know all the pieces of information we need. We know a, and we know the 2 values inside the brackets as well. So that's all we have to do with this question. No need to expand, just leave it in this form. Okay, so once again we're given some information, and once again we have to decide which one of these 3 we're going to use. So we've got the turning point, and we know that it passes through point 33. Well, this is the one that's already in turning point form, so that's the one we're actually going to use. And just confirming that. So now we substitute in the information. Since we know the turning point was at 2, 6, we can make that x minus 2 all squared plus 6. The only thing we need need to work out is what the A is equal to, and that's why we use that 0.33. So the 0.33 is going to be telling us what the A is equal to. So here, that's our unknown. We substitute in x equals 3, y equals 3. Just work it through with the equation. We end up getting A is equal to -3. Once we've done that, we've got all the information we need. We've got A, and we've got the values at the turning point, and so everything is outstanding, isn't it? And now, in this particular question, we've got 3 points. Now, they're not the x-intercepts this time, they're not the turning points, so they're just 3 random points on the parabola, and what we've got to try and do is to work out the equation. So our choice is going to be number 3 this time, because when we've got 3 random points, we just use the ax squared plus bx plus c. Let's see how this works. So what we need to do is we need to substitute in x equals 1, y equals 4. That gives us our first equation here, subbing it into ax squared plus bx plus c. Good news is, with the 0, 5, that means we just get one of the unknowns straight away. It turns out to be c is equal to 5, because that's going to be the y-intercept. And with the last one, we've got 10 is equal to a minus b plus c, and we find that by substituting in -1 and 10. From there, because we know that c is equal to 5, that means that equals 5 there, and that means that equals 5 there. So we've now able to take the 5 across the other side. 4 minus 5 is -1, which explains the -1 there. And we take the 5 across here. 10 minus 5 is equal to 5, and that's where we've got that 5 up there. Well, once it's in this form, it's a pretty easy simultaneous equation to go ahead and solve, and that's exactly what we do. Now, in this particular question, it said find the rule for this parabola. So even though we might know A, we might know B, we might know what C is equal to, we're not finished until we finally write down what the actual equation is, or what the rule is, because that's what the question has asked us to do. Answer the specific question. Okay, so we've got a blank screen here, but not for long. So this one, it says determine the quadratic rule for this particular parabola. So what we observe is, because it's going through the origin like so, we already know it's in turning point, so it's like y is equal to a times x minus 0 squared plus 0. But we don't include the zeros, so we can just say that it's in the form y is equal to ax squared. Well, if that's the case, we only need to use one other point, and that's the 0.25. We substitute it in. That gives us a is equal to 5 on 4, and now we can write down what the rule is. So that's a pretty easy one. Okay, let's look and see what's happening in the second one. So this one is also in turning point form, because we've got the turning point there, we can use that. But we notice in this particular case, it's been turned upside down, and we notice it's been shifted up 3 in that direction here. So we can automatically say that the c must be equal to 3. Okay, once we've got c is equal to 3, we need to use another point. So we've got that other point, -3, 1. We're going to sub that straight into our rule, y is equal to ax squared plus c. And as you can see, once we sub it in, we just get a is equal to -2/9. Once again, reminder that once you've actually found out what a and c are equal to, you still need to write down a rule, and there's our rule there. Okay, but wait, there's more. Let's see what the next thing is. Okay, so this is part C, and what we see is that we've got, oh hello, look at this, we've got the 2 intercepts here, and so we can say this is in the intercept form. Remember, the intercept form looks like this: y equals a x minus b x minus c. But the good news is that one of the intercepts turns out to be 0. So that means up here we can make that a times x minus 0, which is x, and the other one is going to be x minus 3, because we know across here that that intercept was at 3. So the only thing we really need to work out here is what the a is going to be equal to. Fortunately, we've got this other point here, -1/8, and we're going to substitute -1/8 into our expression for what y is equal to. This will reveal that a is equal to 2. Once we know that a is equal to 2, it's just a matter of substituting a equals 2 in there, and we get 2x times x minus 3. Not necessary to expand the brackets, but if you feel like you really can't do without doing that, yes, you can if you wish. Okay, let's look at the next one. We'll tidy this up a little bit. So the next one we notice is in turning point form. So we've got the turning point down there at 1, 6. This means you can write it in the form a times x minus 1 all squared plus the 6. We need another point, and that other point is at 0, 8. So what we now do is we substitute that into our expression. We get a is equal to 2, and once again we've actually found out what the rule is equal to. Now, we don't need to expand the brackets, as I said to you before, but if you really must, if you really can't do without it, you are allowed to expand it. You won't be marked wrong, but you are allowed just to leave it in that particular form there. That I'll leave up to you. And now we get to my favourite part of the slide, the bit where you guys have to do some work. And so, out of exercise 3K, there's your question. There's quite a lot to do, quite a lot of things to practice here, and you need to make sure you've got these right before we get to any tests on this, don't you? Well, good luck. That's it for now, and may your maths be good maths, and bye.